Hi, cast and crew of Radium Girls and Cary Grove High School community. My name is Danica Esquivel. I'm a chemistry teacher here at Cary Grove High School. I've been here for about 14 years, and I'm so excited about this year's play, Radium Girls. Nuclear chemistry and nuclear technology is a topic that we discuss in both our honors chemistry and AP chemistry levels here at Cary Grove. I'm so thankful to Mrs. Wayland for this opportunity to talk a little bit about the science behind the story of Radium Girls. So we're going to start by talking about an atom, and an atom has a center called the nucleus, which is made up of protons and neutrons. So if I were to represent protons using magnets, two magnets of the same charge are going to repel. They really fight each other. And if you have a small atom that only has two protons, this may not seem like a really big deal, but there needs to be a little bit of a buffer. So the buffer is the neutron. Neutron has no charge, and it acts as a buffer between the repulsion of the two protons that are fighting in the middle, more or less holding it together. It's the glue that holds the nucleus together. And like I said, if you have a small atom that's only made up of two protons, you probably only need two neutrons to kind of mediate what's going on between the protons. Unfortunately, unfortunately, it is what it is. The a larger atom is going to have a lot more protons, and therefore will require a lot more neutrons to keep that nucleus intact. So it may not just be one neutron for every one proton. It might actually be one or two neutrons for every proton. And in a really, truly large particle, it could be really unstable, and that's when it's going to split. And when we say that an atom splits, it is producing additional particles. So protons and neutrons are flying off of this nucleus, along with the energy that holds the nucleus together. And that energy, the energy and the particles that are flying off of an unstable nucleus that's called radiation. Now, radiation, I find, is a term that tends to really kind of freak people out. And truthfully, this technology is something that we could not live without. The state of Illinois uses our power and electricity is generated from nuclear power plants more than any other source of electricity and energy. And early pioneers, such as Madame Curie, Marie Curie, she, this is a really exciting thing for scientists to discover these elements that are producing energy, that might even, glow. And at the time, it was treated as kind of a cure-all. We saw that the radiation could have the effect of decreasing or diminishing a tumor. And so these new chemicals or these new elements that were radiating constantly were used as medicine. So folks are just kind of, taking this stuff down, not really understanding the effects. And so radiation effects are based on three things. They're based on the amount of radiation, the duration of radiation, and the type of radiation. So radiation in and of itself is not bad. Nowadays, because we know that so many damaging effects really do exist, we tend to be nervous and scared about what radiation could do. But radiation in and of itself, just on its own, on its surface, may not necessarily be life-threatening. It really depends on the length of duration, so how long a person is being exposed, how much, and again, the type. So let's talk about our radium girls. Radium is a radioactive element that is similar to in behavior as calcium. Now, calcium you might recognize as something that we want in our body because it's good for our teeth and for our bones. Radium is going to behave in a similar way to calcium. So it's actually going to bond and adhere to our bones and our teeth. So our poor radium girls that are ingesting maybe tiny amounts of radium, but over a very long period of time, that radium is actually going into their bodies and is adhering to the bones, is reacting, it's part of the bones, and now it's just continuing to split and release that energy and release radiation constantly. So now you have a source of radiation in your body, and it's not going anywhere. And so if it was raining, you protect yourself with an umbrella, right? If you're going to go into a burning building, then you're going to put on your protective gear, from the heat. When we work in a chemistry lab, we put on our goggles to protect our eyes. There is no protection for radiation, especially when the source of it is in your body. And so the particles, the radium is constantly splitting. And so, there's no wonder that teeth are falling out, bones are literally crumbling. But then on top of that, there's the tissue damage around the bones and around the teeth, to the point where, there's no protection, and those cells in your body are going to get destroyed. They're getting unraveled. So that's why we see mutations. We see damage to anything, heart, lungs, your brain. I mean, all of those things were part of the effects of ingesting radioactive materials. And so it's something to think about, that these folks that were pioneering and learning so much, but unfortunately at a cost of damage to their bodies. So it's definitely a story that it weaves through the science and the history, and I can't wait for the play. I'm very excited to see it all come together. And thank you again for this chance to share a little bit about the science, but I'm really excited to see the play. And so best of luck to you all, to the cast and crew, and good luck. Break a leg.